Good morning friends, welcome to online classes. In previous session we have discussed adjoint of a matrix, how to find a square matrix having 2 order and 3 order. So today we learn inverse of a square matrix. So first we have to know how to possible to find a square matrix. So inverse of a square matrix, that means let A be any square matrix. We have to find inverse of square matrix means it must be a square matrix. So A be any square matrix, then the inverse of A is denoted by A to the power minus 1. So it is called inverse of A, and defined as inverse of A is equal to 1 by determinant of A into adjoint of A. In previous class we have discussed how to find or how to evaluate adjoint of a matrix, of a square matrix. So in inverse of A, we have to find inverse of A. That means we first come or calculate adjoint of A and determinant of A. But here is the condition, and the condition is determinant of A is not equal to 0. So this is the formula to evaluate inverse of a square matrix. So there is some points to find the inverse of a square matrix, that is, when we note inverse of a square matrix exists, that means we have to find inverse of a square matrix is possible or exists if its determinant is not equal to 0. If determinant of any matrix is 0, then we cannot define or we cannot evaluate inverse of a matrix. Okay, so inverse of a square matrix is possible if determinant of a matrix or determinant of it is not equal to 0. The second point is if A inverse exists, then A is inversible. Inversible means its determinant is not equal to 0. So here is the third point. A square matrix A is inversible. Second point, third point are equal. Then a square matrix A is inversible. That means determinant of A is not equal to 0. Determinant of A is not equal to 0 means it is inversible. Okay, so we can say in other words non-singular. If determinant of A equal to 0, that is called singular. If determinant of A is not equal to 0, determinant of A is not equal to 0, that means it is non-singular. So you can say non-singular is same as inversible. Okay, so it is possible to find the inverse of a square matrix, then determinant of A is not equal to 0. So if we evaluate inverse of a matrix, then first we have to find determinant of its determinant is 0 or not. So let's take an example. First we take an example of second order and third order. Okay, now example, take an example. Find the inverse of a matrix 1, 3, 5, 2. Suppose we take a matrix having second order, that means it contains 2 number of rows and 2 number of columns. So it is a second order matrix. So find the inverse of this matrix. Okay, so how to solve? So here is the solution. First we take let A is equal to 1, 3, 5, 2. As you see the formula of inverse, that is determinant inverse of A is equal to 1 by A, determinant of A into adjoint of A. And here is the condition, that is determinant of A is not equal to 0. So first we have to find determinant of A is 0 or not. If it is 0, then we cannot evaluate. So first we have to find the determinant of A. So here are the values of this A. So here is 1, 3, 5, 2. You can be right in the determinant mode. Okay. So we can evaluate, that is 2 minus 15, that is minus 13, and which is not equal to 0. So here the value is minus 13, that is not equal to 0. So inverse exists. That means we can evaluate inverse of A. So first we have to find determinant of A. Then we can find value of adjoint of A. If you find the adjoint of A, then first we have to find minor and then cofactor. Okay. So as you see, the number of elements is 4. So there are 4 numbers minor. So here we can write M11 is the position of these main values, M11, M12, M21 and M22. Okay. So first we have to find M11. As M11 means it's the position of this element. So we have to evaluate the minor of 1, 1. That means we can deleting the rows and column of this element. If we deleting rows and columns, then we get only 2. So here is the value of M11. Now we find the M12. M12 means it is the position of 3. You can evaluate, or you can be deleting these elements, so you get 5. Similarly, M21. M21 means it is a position of 5, so it can be deleting rows and columns, then we get 3. Similarly, M22 is deleting, then we get 1. So these are the minor of this matrix. Okay. So now find cofactors C11, C12, C21 and C22. So as you know, if how to find cofactor, if we add them, it is an odd, then can change the sign. If it is an odd, so even, then you can write the same values of the minor. Okay. So if we add 1 and 1, that is 2, and 2 is an even number, so we can write direct as you write in minor. So there is 2, and there is, if we add them, then it is odd, so you can changes the sign of this corresponding minor. So that is minus 5, minus 3, and you can write directly 1. So these are the cofactor of these elements. So now we can find adjoint of A. So adjoint of A, you can write directly as you here the 4 number of elements. So if we write first 2 number in first column, then 2 minus 5, and the next 2 number you can write in second column, that is minus 3. So this is the solution of to find adjoint of A. So inverse of A can be possible. We have to find only 2 terms, that is adjoint of A and determinant of A. So we will already find determinant of A and adjoint of A. Now we write the formula. So if you write inverse of A is equal to 1 by determinant of A into adjoint of A. If we put the value of determinant of A, that is determinant of A is minus 13. So here the minus 13, and adjoint of A is 2 minus 3 minus 5, 1. So that is the solution of this matrix. If you multiply this element, if you, this is also a solution, or you can multiply this color, then we get minus 2 by 13, 3 by 13, or 5 by 13, or you can write 1 by minus 13 or minus 1 by 13. You can write this form or this form. Both you can write. Okay. So this is the solution to find inverse of A. So we can take an example of second order. Now we take an example of third order. So take another example. find the inverse of the matrix 1 3 minus 1 0 5 2 4 4 1 0. So we have to find the inverse of this matrix. Okay, so this is the solution. First we take let A is equal to 1 3 minus 1 0 5 2 4 1 0. So first we take and let A is equal to this matrix. Okay, so first we have to find the determinant of A. If determinant of A is 0, then cannot define or we cannot solve this matrix. Okay, so first we have to evaluate this determinant. So here is the 1 3 minus 1 0 5 2 4 1 0. Now we can expand this expression along. Suppose we take column 1, expand along C1, because we can expand C1 because in C1 it contains 0, so we can evaluate it easily, or we can be expand R1 R2 R3 anyway. So in this problem we can expand in C1 or column 1. So if we evaluate in column 1, that is 1 into, if you deleting this element, then we get 0 minus 2, okay, and then minus 0 into 0, so we cannot write. So next value is plus 4 into, if you deleting this element, that is 6 minus 1 minus 5, that is plus 5, okay. So minus 2 into 1, that is minus 2, 11 into 4, that is 44, and we get 42. So here determinant of A is not equal to 0. So as determinant of A is not equal to 0, so inverse exists. So you can write A inverse exists. That means it's possible to find out the inverse of A. So next we can find the value of adjoint of A. So we have to find first minor, then cofactor, then adjoint. So as you see, there are 9 elements, so you have to find the 9 minors. So you can write the systematical order, that is M11, M12, M13, okay, M21, M22, M23, M31, M32, and M33. So there are 9 minors to find out. So first is M11. M11 means the element of 1. If we deleting this element, that remaining value is 5210. So we can expand, that is 0 minus 2. Okay. So 0 minus 2, that is minus 2. Next is M12. M12 means 3. If we delete this element, 0 minus 8. So you get minus 8. M13, that means this value. If we delete it, then 0 minus 20. So we get minus 20. Then it's M21. This is the position of M21. If we deleting this element, then 0 minus or minus 1, that is plus 1. Okay. So you get 1. M22. This is the position of this element. If we deleting, then you get 0 minus or minus 1, minus 4. That is plus 4. M23. M23 means this is the position. If we deleting, then we get 1 minus 12. Okay. So we get minus 11. M31. This is the position. So we get, if we deleting, then 6 minus or minus 5. That is 5. That is 11. M32. If we deleting, 2 minus 0. That is 2. And the last is M33. If we deleting, then 5 minus 0. That is 5. So these are the minor of this matrix. Now we find the corresponding cofactors. So C11, C12, C13, C21, C22, C23, C31, C32, and the last one is C33. Okay, so these are the cofactor. In third order determinant, we can write the cofactor is just another method, that is you can same changes can write. So same changes, or you can evaluate or can be formulate or even form. Okay, so same changes, same change, same change, same change, same change means you can write, if it is, if we first we have to add them, if we get odd then change, if we add then you get even, then you can write the same values. Okay, so these are the cofactor of this determinant. Now you can write adjoint of A. So as here 9 elements, so you can write first 3 elements in first column. So you can write -2, 8, -20. The next 3 elements which you can write in second column, and the third column is 11, -2, 5. Okay, so these are the solution to find out adjoint of A. So now we have to find inverse, because we have to, inverse is possible, then we can find first determinant of A and then adjoint of A. So formula of A inverse A is equal to 1 by determinant of A into adjoint of A. So here 1 by determinant of A. So determinant of A is 42 and adjoint of A is -2, -1, 11, 8, 4, -2, -20, 11, 5. So that is the solution of this problem. Okay, so now take another properties in inverse, that is very, very important in long question category, that is the most important. You can write in a theorem, if A and B are any square matrix, okay, then inverse of AB is possible, that is you can write inverse of B into inverse of A. So that is the formula, and here is the condition that determinant of A is not equal to 0 and determinant of B is not also equal to 0, because it's not possible to evaluate if determinant of A and B are both 0. Okay, so this is the theorem that inverse of AB is equal to inverse of B and to inverse of A, and that is a very important. It is in a long question type problem to evaluate, that is we can take an examples. We can, if A is equal to 1, 3, 5, 4 and B is equal to 2, 0, 0, 4. Okay, 0, 6. So A and B are both are square matrix. Then you have to verify. Then verify that inverse of AB is equal to inverse of B into inverse of A. So that is a theorem to verify. Now taken a solution. Okay. So here first we have to write let A is equal to 1, 3, 5, 4 and another matrix B, that is 2, 0, 0, 6. So first we have to find determinant of A. So determinant of A is 1, 3, 5, 4. That is 4 minus 15. That is minus 11. Similarly, determinant of B is equal to 12 minus 0. That is 12. So first we have to find determinant of A and determinant of B. As you see, inverse of A, that means we have to find adjoint of A, and inverse of B, that is possible to find first adjoint of B. So first find determinant of A and determinant of B. Then cofactor of, so minor of this determinant. Okay. So minor and cofactor of the matrix A. First find. Okay. So here you can separate these. So first is M11, M12, M21 and M22. Okay. So M11 is 1, that is deleting, then 4, M12 is deleting, then 5, M21. So M21 means 5 is deleting, then we get 3, and M22 is get 1. So these are the minor, then write cofactors C11, C12, C21 and C22. So C11, so C11 is 4 minus 5 minus 3, 1, and write then adjoint of A. So adjoint of A is 4 minus 5 minus 3, 1. So this is the adjoint of the matrix A. Similarly, you can evaluate determinant of B. So there is minor and cofactor. You can write cofactor of B. So here you can write M11, M12, M21, M22. So M11 is, you can see in the matrix B. So you can write M11 is, if you delete it then you get 6, M12 if you delete it then 0, M21 0, M22 that's 2. Okay, now you can write cofactors C11, C12, C21, C22. 6, 0, 0 and 2. So next write adjoint of B. So adjoint of B is 6, 0, first 2 elements in first column and the next 2 elements in second column. So here is the solution of adjoint of B. So adjoint of A and adjoint of B both are found. Then we can evaluate inverse of B and inverse of A. Then in case of AB, so first we have to find AB. So first we have to evaluate A into B. So first we write determinant of A is 1. So matrix of A is 1, 3, 5, 4. Now first you can evaluate inverse of A, inverse of B. So inverse of A is equal to, as you know, the formula of inverse of A is equal to 1 by A. So 1 by determinant of A is minus 11 into 4 minus 3 minus adjoint of A. Okay. So this is the solution of inverse of A, and inverse of B is equal to 1 by 12 into 6, 0, 0, 2. Okay. So inverse of A and inverse of both are found. Next, both inverse of A and inverse of B can evaluate. Then we have to find inverse of AB. So first we write A into B. So here A is 1, 3, 5, 4 and B is 2006. First we have to check it is possible to multiply or not. As you know, it is 2 into 2 and it is also 2 into 2. So it is possible and the solution must be a 2 into 2. So these are the 4 elements. First is 1 1, that is first row, first column. That is 1 into 2, 2 plus 0. Similarly 1 2 this means 0 plus 18, and it is 2 1 second row first column, 10 plus 0, and the last one 2 2 0 plus 24. Okay, so that is equal to 2 18 10 24. Okay, so first we have to evaluate AB, then minor and cofactor of AB. Okay, so first write M11, M12, M21 and M22. So minor of M11 means you will be deleting this element, so you get 24, M12 is 10, M21 is 18 and lastly M22 is 2. So as you find M minor, then you can write cofactor here. So the cofactor are 24 minus 10 minus 18, 2. Then you can write adjoint of AB. So adjoint of AB is first two element is first column and the next two element is minus 18, 2. So that is the adjoint of AB. Now you can find inverse of AB. So inverse of AB is possible. First we can evaluate your determinant of AB. So this is missing. So determinant of B is 24 into 2, that is 48 minus 180. Okay, if we subtract, then we get 2, 7, 3, 132. Okay, so inverse of AB is equal to 1 by 132 into 24 minus 18 minus 10. So minus 130. So inverse of AB is equal to 1 by minus 132 into this matrix. Okay. So here we have to verify. So we take an LHS. So LHS is inverse of AB, that is the solution. And then next is the LHS is inverse of B into inverse of A. As you find it, first inverse of B is 1 by 12 into 6002 into inverse of A is equal to 1 by minus 11 into 4 minus 3 minus 5, 1. Okay, so you can put the values. Now we can multiply first the scalar 12 into 11 and this is minus, so minus 1 into 130, minus 1 by 132, and the next multiply this matrix to this matrix. So you can write 6 into 4 24 plus 0 minus 18 plus 0 0 plus minus 10 0 plus 2. Okay, so minus 1 by 132, that is equal to 24 minus 18 minus 10 and 2. So you can check the inverse of AB same to inverse of B inverse into A inverse. So you can write LHS, or you can write inverse of AB is equal to inverse of B into inverse of A. So this is the verification of AB inverse of AB is equal to B inverse into A inverse. Have a nice day.